There will come a point where we would like to graph polynomial functions. One of the things that helps us graph a polynomial function is what we call the leading term test. Remember that the leading term is the term that has the highest degree. And so if we identify that particular term, then the ends of the graph are going to look like whatever that term acts like overall without the rest of the terms considered. So on here, for example, any kind of graph that we have is going to act like one of the four examples that I'm about to show you. And what we mean by act like is at the far ends, as you approach positive and negative infinity, they're going to have particular behaviors. Okay, the first example that I want to talk about is if your leading term has a positive coefficient and an even exponent. So here I've written a positive times x raised to an even exponent. And here I'll give you an example. So let's say that we have something like y equals 12x to the fourth. And let's say that that is our leading term. So if that's our leading term, we see that the 12 is positive, we see the exponent is even. If that's the case, then our end of the polynomial will both open upwards. Now y'all see I've put jaggy stuff here in the middle, basically meaning that the polynomial can do anything in the middle, but I know that both ends will open up. The way that I remember this is I think of the example x squared. X squared has an understood positive in the front. A parabola we know opens upward if we have a positive value in the front, and that exponent is obviously even. So that's the one that I usually use to remember this particular behavior. Next example over, let's say we have a negative as the coefficient and we're multiplying by x to also some even exponent. So as an example there, let's use just a simple y equals negative 3x to the second. We see that we have a negative coefficient of 3, and then the power on our x is an even number 2. In this case, both ends will both open downwards. Okay? A lot of stuff can happen in the middle, but both ends will be pointing down. The way I remember that is just to remember the simple example, negative x squared. I know that both ends are going to open down because of the negative out in the front. Both ends are going the same direction because it's a square. Alright, next example over. Let's say I have a positive coefficient, but my exponent is now odd. So for example there, let's say we have something like y equals 5x to the third. So we see that coefficient in the front being positive 5, but then we see an exponent that's odd. If that's the case, both ends go opposite directions. In this case, the right end goes up and the left end goes down. And I use squiggly lines in the middle, meaning anything can happen in the middle, but the ends are what I'm interested in here. The example that I use that I know something about is x cubed. X cubed I know is a graph that looks something like this. The right side goes up, the left side goes down if it's positive in the front. So I can remember that simple example and kind of relate that to what we're learning here. Finally, the last one, if I have a negative coefficient and an x raised to an odd power, let's use it as an example, y equals negative 7x to the fifth. So we have a negative coefficient in the front, the negative 7, and we have an odd exponent of 5. That, the ends go in opposite directions, but the left end goes up and the right end goes down. As an example there, I can think about this function. Well, that particular function, because it has a negative in front of it, I know that my left side is actually going up and right side is actually going down. Okay, to review and recap, what you need to know here is if you have an even exponent, the ends will open in the same direction. So notice here that both of these have even exponents, and both examples have the ends going in the same direction. If you have a positive coefficient, they both go up. If you have a negative coefficient, they both go down. Notice then, if you have odd exponents, the ends go in opposite directions. What I remember is if it's positive, the right end goes up. If it's negative, the left end goes up.